My name is Sriram. I'm the Director of Product Management here at Arista Networks, part of the Cognitive Campus Business Unit. I'm going to give you, since we met at the last Mobility Field Day, I want to give an update on what we've been working on the AIOps side, right? More so on the troubleshooting. But before I do that, I think just to set some context, I want to kind of walk through the key capabilities of the product. These are things that we have presented and showcased in the past Mobility Field Days. But just to set context, I'm going to take like 2-3 minutes just walking through the core capabilities. The first is we've always talked about how we provide end-to-end visibility of the user experience of all the clients connected to the network, starting from connectivity, where we track every single event as a client tries to connect to the network, and tell you where if they have issues connecting to the network. Second is once they connect to the network, we track every single RF metric of every client in very granular intervals. And when there is an anomaly, we call that out and show what the health of the client is in terms of RF. And finally, once a client is connected, using our patented algorithm, right, that Karan and the team built, we not only can track the interesting applications on a per client basis, but we can understand the application experience on a per client per app basis for both collaborative apps like Zoom, Google Meet, WebEx, etc., and also for TCP-based application. And we talked about this, multiple times. We presented this in the last Mobility Field Day. Karan, did a presentation in WLPC. So this has been our core capability on the platform. And then we also talked about how we can, go back in time, look at logs, dynamic packet capture, using a multifunction radio. And then what we've also showed in the previous Mobility Field Day is once you detect an anomaly, the admins can go into a platform and invoke our RCA engine on demand, right? So they can, like when they get an alert, they can say, find me the root cause. And what the RCA engine will do is it will answer questions like, why are clients having poor RF performance, right? So they'll try to map the symptom to the cause. It also helps answers questions like, which locations have bad RF performance? Is there a specific set of clients that have poor RF performance, right? So we're trying to correlate the key attributes that is cause of that issue. And
is that an if-then correlation, or are you actually using like an AI/ML to look at what those mean and identify anomalies?
Yeah, it is a combination of both, Sam. Karan, do you want to just just quickly add on to that? I know you had a big presentation on WPC, but if you want to.
Yeah. So no, it's not rule based. So there is domain knowledge into it, like what can cause what, right? So there is a dependency graph that is built into it, and we also look at how the system is configured before providing recommendation. But the core algorithm is ML based, which actually tries to find the most correlated root cause out of the many that are possible. Yeah.
Thank you.
Yeah.
Thanks.
Yeah, again, I think our approach to AML, and I want to kind of call it out, is we don't want to build AML just for the sake of building it, right? It's not a case of like a solution searching for a problem, right? I think for us, it starts with a clear problem definition on what we're trying to solve. A good example of this was application of this was trying to detect whether an app is good or bad, right? So that was a problem, and you could solve it in many ways. And to us, AML is just a means of solving problems. And then what the RCA engine does is it in some cases it'll provide recommendations that the admins can go take and to resolve the issues. So the other thing that we've talked about, which is again unique to us, is our multifunction radio, right? We've been shipping this for the last couple of years. All our enterprise AP comes with a dedicated multifunction radio, and the multifunction radio scans, right, and also can act as a client. The scanning information is fed. It's a tri-band scan. It is fed back into our RRM, into our WIPs, into our use for troubleshooting like spectrum analysis, packet capture, use for locationing, right? And the unique differentiation for us is that same radio can act as a client and simulate end-to-end traffic testing all the way from the client to the app, and can tell you where the issue is if there are any, right? So that's something we've talked about. We've showed this, specifically the client connectivity test. So what's new? So if you look at our AML engine, the first thing it does is it looks at all the key KPI metrics that define the health of a network. We have multiple of them at very granular level, and whenever there's an anomaly, we detect that. That's the first step, right? We detect the anomaly. And today, like I said before, the admin would have to go and do an on-demand invocation of the root cause analysis engine. But what we are announcing is a step ahead, which is our RCA engine runs 24/7 all the time. So whenever there is an anomaly, our RCA engine will automatically look at the metrics, look at the logs, will recommend we'll try to find the root cause, find the recommendation, and then send an alert, right? So this is pretty big for us because, as you can imagine, the RCA engine is highly compute intensive, but we have optimized to run it on the cloud. And our eventual goal is to get to a point where we can take some of these actions by ourselves. But that's a journey we continue to march on, right? So this is we think this is the next step in terms of getting to our end goal.
So building on the point of progressing eventually to taking action yourself, that recommendations to the network admin, does the admin then have to go and do it, or do they just say, do they tell the system to do it and the system can do it? I guess I'm asking how far into the take action yourself.
Yeah. See, I think I'll tell you the biggest challenge in building a recommendation engine and then implementing it is actually to come up with a recommendation, right? I think we have solved the hard part of coming up with a recommendation, which is going to be the toughest part. And then now either you tie that automatically or you create a workflow is more of a UI UX workflow that we need to build. But today, yes, I mean the first phase is we come up with a recommendation and the user can come in, look at the recommendation and make the config changes or whatever the recommendation says. But I mean, you can imagine the next step would be to allow workflows to make that much more integrated. But we feel the toughest part of like building the recommendation is solved. We are past it. At least for again, I think the problems in networks are going to be varied, right? So different problems will be in different state, and that's how we look at it. Like I said, we don't look at AIML as a solution looking for a problem. We first start with problems in the customer network, and problems. I mean, usually input to that is actually from attack, right? Because they're the ones that are dealing with the customers. But I hope that answers the question.
Yeah, I think it does. I mean, ideally, I like keeping the network admin in there as sort of the gatekeeper to say yes or no.
Yeah.
But it would be awesome if it was just see the recommendations. Yes, I agree. Click a button.
Yes, absolutely.
And then goes and does it.
Absolutely, yes, yeah. So there'll be at the end, the admins control the network, right? Because they might have said something in certain way because of certain context that may not be captured in the system. That intent might not be captured in the system, and we'll always have the admin have the last say.
So as far as your correlation engine goes, how can you go pretty deep into the infrastructure? Like, just let's say a theoretical. Let's say that you've got a switch where the uplink fiber gets kinked. So your optics are showing LOS or signals below a threshold, which is causing issues for all of the clients connected to all the access points connected to that switch.
Yeah.
Can you give me an alert that says LOS or signal issues on this optic, and all of these problems we believe are correlated to this, this switch? Is it that far along?
John, thank you. That's exactly what I'm going to show in a demo, right? Hopefully,
this was not set up. I was just honestly though.
You have a very valid point, and we'll kind of explain how we are getting there, right? Because sometimes we may not have the telemetry from all the systems, right? We are limited in telemetry, but then we'll explain with the telemetry that we have,
And I'm assuming if I have Arista access points plugged into an Arista switch, in this, I'm not expecting to be able to do that with just any random switch. But with your own hardware, can you go that deep?
Yeah. So I'll walk through the demo, and then as we go through the demo, we'll answer some of that. So okay, so folks, so what I have here is it's a so we actually ran into this issue in our internal network. So essentially, the demo is just play up a scenario, right, which is users at a particular location at a particular site are having issues with a very specific app. It's an internal app. It's called internal Git, and essentially, what the RC engine does is whenever there is an issue with the app, we track it, and when we track it, we run the RC engine automatically. The RC engine, kind of correlates, tells you, what the issue is, right, and then sends you a feed. And this is exactly what the feed will look like, right? And the feed can be integrated with your, SIM system, with Slack. In this case, it's a Slack. So here it says poor application experience. Notices location alpha anomaly exists since 9 a.m. today, right? And the top root causes and correlations are app name internal Git. So just by looking at this, you know that it's a site-wide issue because it's in the location, right? And then it's impacting internal Git. Now, how do we get to more details, right? So let me click on this and get to the dashboard.
While you're doing that, it also can do Teams.
Yes, yeah. So collaboration apps, all the collaboration apps.
Okay.
Most of the popular ones.
IRC?
Keep it real.
Oh, Sam.
So old.
All right. Okay. So when you clicked on that link, it got me here into this network feed. So again, network feed. Think of this as the output of the RCA engine showing up in your dashboard. So here, the first thing that you would notice is, it says 27 out of 32 clients are impacted by application issues, right, at this location. So the first thing it did is it actually just said, you know what? So it looks like it's not an issue with a specific client. It's an issue with multiple clients at the same site. So it's not. It's necessarily not a client specific issue, right? So we're trying to isolate the issue. It's at a specific location called Pune Alpha, and it also says that the top root cause and correlation is with this very specific application internal Git. Okay, so this is the summary or the output of the RCA engine. Now there's a lot of logic that goes behind, to come up to this conclusion, right? And that's the power of RCA. And I'll talk you through all the data points that we have that that the RCA engine took to get to this conclusion. Okay, so very quickly, you can see that the issue has been happening for the last 6 hours. Again, this is a demo system, so we kind of generated this the scenario. But the next thing you would want to see is, let me go look at what's happening with the app at the site. Okay, so now this is the app dashboard, right? Now just by coming here, I can clearly see at this site, right? So I'm at locations Pune Alpha, right, on top left corner. This is a location I'm in. You can see that it's only one particular app that's impacted. Every other app is green. So right off the bat, I know it's it's an issue impacting only this application. Okay, again, how we isolate the problem domain. The second is, now we want to know, is there like, so now we know that issue is with the app. The next thing you want to know is, okay, is my RF okay, right, at the site, or is it an issue with the LAN? Is it an issue with the WAN, or is the issue with the application itself, right? So to prove that your RF is okay, what we do is you can go back to performance, right? This will tell you at the site level, right, what are the top RF issues? How is the RF health of all the clients? And very clearly, you can see that I don't see anything bad. There are no clients with low RSSI, no clients with high data rate, 2 clients with low data rate. But that's not good enough correlation for the root cause engine to say that the app issue was correlated to RF, right? And that's why that recommendation did not come up. Again, the reason I'm kind of walking through all this is this is how the RCA engine kind of goes through in the backend, right? The output you see in the feed is very simple, but there's a lot of logic. It's just like how we troubleshoot a network, right? That's exactly what the RCA engine does. So the RF looks absolutely fine. Okay, so now let me go back to application. At the site level, RF looks absolutely fine. So let me see if there is, if there are anything more proof points on a specific client basis, right? So I'm going to click on this one particular app, internal Git, right? So this tells me a list of all the applications that are impacted by that app, right? I'm probably going to pick one client. Let me pick the first client. And when I pick on the first client, again, if you look at the top RCA recommendation, it says it is a potential wired network issue. Okay, so in this case, the correlation is, look at the App Engine. We said we're trying to isolate the problems here, right? Problem domains. We isolated RF. We isolated, based on the fact that other applications are doing good, but only this app is bad. We also isolated that it may not be a WAN issue, it may not be a LAN issue, it's just with the app, right? So again, just showing the amount of data that we use to come up with RCA. And we also want to ensure that the RF metric for a per client is good, right? So if you look at the data rate, they all look great. I'll go click on retry rate. For the last 12 hours. Okay, the retry rate looks really good. I don't see any anomalies. RSSI, they look good as well, right? So again, on a per client basis, everything perfectly looks fine on the RF. And let's see if this client also has exhibits similar issues with other apps, right? So on a per client basis, this I'm on a particular client. This again proves that the issue is only with internal Git. This client has been having no issues with Google Drive or Dropbox or Salesforce or Google Meet. And that's how we came to that recommendation, right? So we collect all this data, analyze all this data, and then we come up with that recommendation saying the issues with the internal app. So John, I think to your point, yes, we in this case, it's mostly problem domain isolation. Really saying, looking at the metrics and saying which may not be a problem domain, and really helping to get to the root cause of the problem and reduce the mean time to innocence, right?
So what I would love to see, as an idea for going forward would be, you recently, and we're going to be talking about it soon. We launched the WAN platform, whatnot. So if I see this, what I'll go is, okay, Google Drive, Dropbox, Salesforce, Google Meet, those are all internet applications. Internal Git, I'm going to guess in my environment, that would mean it's hosted in an internal data center somewhere.
It is.
So to me, that would lead me to say it's an internal WAN issue, not an internet issue, right? It's a sort of SD-WAN issue or whatnot. And it would be great if you guys are able to pull in the data from all of the elements to, at least the ones that you control, for the product you sell, to say, okay, and so this WAN path is having issues, and that's what's causing the internal Git application to be slow. I mean, that's probably a ways out, but I'm guessing that's where it's going to go.
Absolutely, that's where it's going. You're setting the roadmap for us, but yeah, hopefully, in the coming mobility field days, we'll be able to demo some of that.
Can I add just one point to John's question? So there are actually two separate efforts which will converge. One is there's a separate effort looking specifically at the optical SFP and what is happening there, and is there a real issue happening with the SFPs, and are we suffering loss of signal, high temperature, or any of those kind of things?
That was a pretty deep cut there.
Yes, right. And there is actually a working model today we have, but that's kind of focused specifically on the SFP and its performance characteristics. Now the question is, can we take that and mix the two? The answer is yes. We don't have it yet, but that's kind of where we are going at this point. So it's kind of reinforcing what Sri was saying.
So from my point of view, this is problem identification, not root cause analysis, because it's identified a problem with an application, but not why that application has a problem.
So it's problem domain isolation, Peter. So what we mean by problem domain isolation is we look at all the metrics. I mean, so for example, right, if the same issue had happened, and if we had found RF issues, right, we would have actually said this. The root cause would have been very different, right? It would say RF issues, and that's why I said this looks like at the top level looks simplistic, but the kind of logic that goes behind before we come up with this is what I walk through, right? It's like any of us walking through. Oh, if I have an issue, okay, I want to isolate the problem, right? Okay, RF check mark, LAN check mark, WAN check mark, right? And then I'll start correlating. Okay, I see patterns, right? Every other app is okay, internal Git is bad. Oh, maybe it's an app problem. That's exactly the process that we go through in the backend and come up with this recommendation. Karan, do you want to add anything more, Karan, on this?
So I think what Peter means is, I guess that if it's an RF, probably then that might have been a root cause. But in case of LAN, it's not really a root cause because yes, it identified it, but not really a root cause.
Yeah, correct. So it's a problem domain isolation. Yeah,
Right,
you could call that.
Yeah.
How do you?
So I think.
Go ahead. Sorry.
Go ahead.
Yeah. So if this exact event were to occur, let's say on a campus during graduation day, I've got 20,000 extra people in there. My airtime usage is higher. My noise floor is higher. Would that start looking at RF, or is there other logic there as well that's saying no, it's still a wired problem because the RF is now well beyond baseline?
Baseline, yeah. So absolutely, we will actually tell you what exactly the RF problem was. Karan, do you want to add?
Yeah. So see, in this root cause analysis, right? So we have looked at RF, and which has been basically eliminated in the sense that it's not the reason. So if we see an RF issue, so for example, Shri, if you can click on that anomaly there, right? So in this case, which happened a while back, you can see that it did root cause analysis for an RF issue, and it's clearly calling out that there are multi-band clients operating in 2.4, right? So we do evaluate RF issues. So the demo that Shri showed is specific to an application where there were no RF issues and still we were able to pinpoint. Obviously, if we have more data coming in from the wired system, right, then we can correlate that and pinpoint precisely if there is an issue with the switch and so on. So that is in works, as Kumar also pointed out.
Yeah, but just to add on, so this is an example, right? So here, in this use case, again, this is a live example of a customer scenario where they had configured client limit on every AP, right? So they've configured to 20. So and what happened was one day there were like a huge congregation of people on one floor, and in the training room, and then the first 20 clients connected to 5 gig, the next 20 clients connected to the 2.4. And then the rest of the clients actually connected to the hallway AP on 2.4 because that was the best signal that they could get. And our engine will identify that there are 5 gig clients operating in 2.4. And if there's a sticky client issue, it will identify sticky client issue, and that will be the root cause of this issue. So again, this also correlates back to application issues, right? So in that case, if those clients had app issues, it'll say, hey, you know what? This is because I have clients that are 5 gig capable operating in 2.4, and I have clients that are exhibiting sticky client behavior. And if you go click on this, you'll actually see low RSSI. But yes, we like for RF, we'll actually give you the exact metrics and exact root cause.
In the example you provided for the internal Git app issue, where we said it's a wired LAN issue, am I able to send the LAN team, hey, this is what we're seeing on our end, and these are the reasons we're kind of thinking it's a LAN issue?
Absolutely, yes. So what you could do is you could actually run a client connectivity test, right, from a third multifunction radio, make it as a client. You can configure a test, you can run it on demand and say, hey, run a test to Git internal. It'll do authentication, DHCP, AAA, everything will be okay. It'll do a bunch of ping test, also curl, and that will show latency. And you can use that report to tell your application team that, hey, something is wrong with internal Git. So
on the application side, do you have support for Teams and Zoom?
Yes, Teams, Zoom, Google Meet, all the popular collaboration apps.
Feeding back root cause analysis into configuration. Let's say you've got an old client that doesn't support DFS channels, and the fix shows up as a sticky client, but really it's to turn off these channels, right? So it's something esoteric. How are you exploring feeding that back into a configuration recommendation as opposed to hey, it's a problem with the client in a scenario like that?
Yeah. So Sam, I think that's an area of constant development, right? Again, it's very use case specific. Your specific use case, today we provide a generic recommendation, but yeah, it's a constant. It's an area of constant investment for us, and we are progressing.